Hi nReduce. This week, instead of working on what we had planned previously, we did some code cleanup and internal changes. So rather than showing you some new features, let me walk you through some LiveReload internals. Hope it will be interesting. As you know, LiveReload is a native application, but most of the logic is implemented in Node.js, and we've moved even more logic into Node. Let me show you how this works. So this is a .NET application implemented in C# with native layout expressed in XAML, like it is supposed to do. A similar Mac application has native layout expressed in the interface builder in Xcode. So these are all native controls. But on top of that, there is a framework that binds these native controls to Node code. Like this. Here is an example of main window class, which corresponds to that window that you saw on the screen. And it communicates with Node through JSON encoded messages. It communicates with native app through JSON encoded messages. So basically, Node app is executed in a separate process, and it changes JSON payloads with the native app. And basically all controls are proxied to the Node side. So there is a projects tree view which is called tree view projects. These are not actually my favorite naming convention. It's kind of stupid, but we're going to change it. So anyway, okay, so yeah, this is the main window class. And one thing to note is that it can send updates to native controls like this. This updates the entire tree view of projects. And this, somewhere at the bottom, this, for example, updates the text of a text box control that displays a snippet or URL window or whatever. This is one thing to note. Oh, and yeah, in the reverse direction, this is an event handler that says that when a text is changed in this control, this handler is invoked. And because this handler is present in Node class, it is automatically hooked on the native side, and the native code listens for the text event and sends any updates here into Node. Another interesting thing is automatic dependency tracking. This is something we made a few iterations on over the summer, and we had different approaches. So this is the latest one. Let me show you, for example, the project class, which holds all the information about the folder you have added to LiveReload. So here is a class. It defines a simple schema for some internal purposes. For example, let me show you that snippet field. If we go into the native app, here is a snippet, and as I type sunsets, let me scroll it back. So as I type stuff, you can see that snippet is automatically updated. So basically, snippet depends on the URL field. Here's how it looks in code. Snippet field is declared as computed, and down below there is code that computes a snippet based on URLs set up for this project. Nowhere in this code, basically there is no code that set up to track when URLs are changed and recompute the snippet or something like that. It's simply the fact that we read URLs in snippet computation function that gives the system information that snippet needs to be recomputed when URLs change. So whenever I type something in the URL field, this method is automatically invoked by the dependency tracking system. Similarly, here in the window, for example, well, yes, for example, here when we render the snippet, this is only one function. It's not called from anywhere here, but because it starts with automatically, it will be invoked on this class creation once. And because it accesses selected project snippet, and snippet is a field tracked by the dependency tracking system, whenever this field changed, this function is invoked again. So whenever the snippet changes, or the selected project changes, because the selected project is also here, it's also a field tracked by the dependency system. So whenever it is changed, or whenever the snippet changes. Where is it? Oh, here, okay. So whenever any of these two things change, this method gets reinvoked and the new value of the snippet text is sent to the control. Similarly, for example, when the list of projects is changed, this method gets reinvoked. So whenever the list of projects changes, we are sure to send the new list of projects into the native site to be displayed. So there is no code to set up this tracking, so there is no possibility to forget something or well, whatever. So this should lead to much less bugs and much more pleasant coding, basically. Can I show you? Another thing is this is a setup to do is to be able to call native methods when needed. So for example, when I click this plus button, I can select a new folder like, I don't know, whatever, and it is displayed here immediately. And the way this works is a handler for add button is invoked, and it sends a special message that tells the system to invoke this method on the native side. Okay, as you probably noticed, it's 6 in the morning here and I'm doing a little bit of babysitting while my wife is still sleeping. So I'll wrap this up real quick. So this method is invoked on the native side. It's our custom methods that we define to display that choose folder dialog. And when it returns, we get a result, and so the path selected in the dialog is returned back to Node, and we can call add project with this new path. I hope this was interesting. So we decided to not release an update this time. We basically only improved the internals. Most of this was built this last week. As I said, I did multiple iterations on this automatic dependency tracking, but I wasn't very satisfied with how it turned out the last time, so I redid it from scratch this time, and it will be a separate node npm package. Well, thanks for watching. Goodbye.